Hi everybody, my name is Angel and I'm going to follow up the precedent video. So, the context is there exists a list who, who started at 1 and the number inside the list need to be positive, need to be integers, need to be mm, consecutive, so like consecutive. And my goals is just optimize the space complexity and the time complexity, especially the time complexity. Like I've explained in the precedent video, inside the precedent videos, in French, I'll explain it. So inside this video, in English, with the JavaScript language and all the Python language. If you want to just understand what's going on with the Python language, you need understand French and look the precedent video. So uh, I'll write, I write the context on the terminal. Just before I need call the framework that I use inside my terminal to write on the JavaScript. So yeah, for the context, like I've explained, we want to do the sum. You want to do the sum for the numbers inside the list who's like who started at 1 up to probably 100. No, not 100, but n. And this is the variable value. Yeah. And all numbers inside the list will be positive, integers, and probably positive integers and consecutive. So I want just optimize, and if I want optimize, I need to realize one thing. If I'm asking you do the sum for 1 plus 2 plus plus 3 plus 4 plus 5 plus 6 plus 7 plus 8 add up plus 100, we just keep going the addition. If I told you do the sum like that with this element, we need just do the first sum like 1 plus 2 equality 3 and memorize the result, and we need to keep this result in your mind, but that's too long because for each element inside the list, if the list is too long, you will lose many time to memorize the result, the sum result for each part, and this sum will be impact by the number inside the list, and that's not efficient. That's not the best method, and it is the same thing for the computer. And like we won't just optimize the computer, the the space complexity, and the time complexity especially. We need just use the formula that we can help me. And for this case, especially for this case, the formula we can help me, it is the Gauss mathematic formula. This is the reason why you can, if you want just move at the linear complexity into the constant complexity, we need to use the formula, the mathematics or the logic. And in this case, the formula is just n times, I'm open the parentheses and I put n plus 1 divided by 2. And this is the formula that we can use for this case. And if you want just check if this formula is great, we need use the recurrency demonstration in the mathematics course. So we don't just prove this formula, because this is the Gauss mathematic formula. We won't just show how code the function for this case quickly with the efficient method in a JavaScript. So instead use the for, use the keyboard for. We need the list like argument, and the number n like argument inside the parameter. We will just, with this formula, one parameter, and like you can see, the space complexity is less compared the first method. So we create the function thanks the keyboard function, and we give the name for this function, for example Gauss. And I'm open the parentheses and I can put just the variable like the parameter, and I open the curly braces, and inside the curly braces we can just put the first instruction. But before I put the first instruction, we need also we need use the local variable with maybe s for some equality. You can put whatever the variable, that's not important to them. And we use just the formula like n times n plus 1 divided by 2. And just after the first instruction in JavaScript, you need to put the semicolon, and this is to keep going or to follow up the precedent step. We need just return the result, and to return the result we need just use constant point log, and I'm open the parentheses and put the second instruction. This is the second instruction out. I did the mistakes. I can just delay and put the point. I'm right hand control. That's good now. Inside, I use the backtick, and I can write, for example, the sum is with the dollar sign to put the variable like the value with inside the local variable s, and I'm close the curly braces, followed by the backtick, and I'm closing the parentheses. The second restriction is achieved, and I need to put again the semicolon before close the curly braces. And the function is great. Is okay. This function is more efficient, and with this case, we just have go to the complexity, the linear complexity to into the constant complexity. We can just use this function with the name. For example, I want the sum for all number who started the list who started at 1 into probably now 200, and I'm close the parentheses, and we can see the result. The result is 40,200, and just with the mathematics we can go so far, because if you master the mathematics and you can understand the formula really, like if you deep diving inside the formula, you can just discover the thing not really discovered, like the pattern, the new patterns. So I hope you can understand me inside this video. Have a good day.